Okay, in this video, I'm going to show you how to plot an estimated position using a known current. We're working on Block Island Sound Training Chart 13205. And we're going to use triangles, dividers, and a calculator. I've plotted waypoint number 1 here and waypoint number 2 here. Here's the Latin long for your reference. And then at 0800, I had a GPS position plotted right here. The course to steer along the track line is 352 degrees true. So at 0800, I found myself a little right of track. No big deal. I plan on I want to get an estimated position for 0818. So using this method with my known current of 090 degrees true at 1 knot, I first have to plot a dead reckoning position for 0818. I can use the 6-minute rule to easily calculate this. I know if my speed is 15 knots, I will go 1.5 nautical miles in 6 minutes. And 18 is 3 groups of 6 minutes. So I know I can multiply 1.5 by 3, something I can do in my head, and find 4.5 nautical miles that I will travel in 18 minutes. You could also use the distance, speed, and time equation and do it in your calculator. Here's 4.5 nautical miles. I start from my 0800 position, even though it's not along the track line, but my DR position must be along my track line. That's a rule. And so I bend it back to my track line and I put 1 hash, half circle, and label at an angle 0818. Now I'm going to apply my known current. Remember that wind is from and current is to. So a current of 090 degrees true is going to push you in the direction of 090 degrees. This current has a speed of 1 knot. That's 1 nautical mile per hour. So if I was steering and basing this estimated position off of a 1 hour position, then I could apply it at 1 nautical mile because that's how far the current would push me in an hour. But I haven't traveled an hour since a known position. I've only traveled 18 minutes. So I need to adjust that 1 nautical mile and reduce it because the current had less time to push me in the direction of 090 degrees true. So first I'll plot the vector in the direction of 090 degrees, and I plot that from my DR position. I don't know how long it's going to be yet, so I'll just make it sort of large, way larger than it's going to be. I know it's going to be in this direction. Okay, 090 degrees. I can also use the 6-minute rule to apply for the current. All right, so if I was only going 6 minutes from a known position, the current would only be able to affect me 1/10 of what it would do in an hour. So I would apply 1/10 of a nautical mile, okay, for 6 minutes. And so I know because 18 is 3 groups of 6 minutes that I could apply 0.3 nautical miles of current onto that vector. If I wanted to use distance, speed, and time to do this, I would take 18 minutes that I've traveled divided by 60, okay? And then I have to multiply it by my nautical miles per hour of 1, and I find 0.3. Okay, so 0.3 is how far the current would affect me in that 1 hour. So I plot 3/10 of a nautical mile. I apply it along the vector. Okay, and I make a tidy hash, and that right there is my 0818 EP. For your reference, I'll get you the Latin long of this EP. The latitude is 41 degrees, 4.9 minutes north. And our longitude is 71 degrees, 40.5 minutes west.